So you guys are in statics? So y'all getting questions? No? You just
Brent
gonna,
said we were learning something new, and I couldn't get my computer to work yesterday, so I'm really just coming in here to see what all I missed.
well, it's all online.
That's true.
So,
I
I was,
have to go home tonight because the Wi-Fi in our dorm is just not great.
really? So can you get the streams then? Can you,
Most of the time, but sometimes whenever I do, it'll just cut out.
really? And it's in the,
It's like that even if you're like watching TV or something. Sometimes you'll be watching for a show and then it'll just like pause and take like 5 or 10 minutes to load.
oh gosh, okay. Is everybody having that trouble? Huh. What about in the library? Can you,
I probably could if I wanted to. I just don't like to play stuff in the library.
Yeah.
It's quite late in there.
so if you do that,
Normally I just like watch them in the evening or something.
yeah.
And there's not as many people on. If it's too
Oh,
late in the evening, then there's a lot of people on.
oh, okay, okay,
Or I do it on the weekends too a lot. I think
okay,
it's whenever I turn on my homework is like almost every weekend. So
yeah.
it's whenever I go home or whenever I come back here and nobody's here.
Yeah, that's kind of what I was trying to structure is that, you could actually turn this into a weekend class.
It's more or less what I have.
Yeah, so, I mean,
And it works.
yeah. And then the other thing is, I hate to say it, but there's probably what, 400 people in your dorm or something, or 200. They're probably all on there at the same time. So, but do y'all have any questions? I mean, because really I'm actually done with this semester. I was just fiddling with this problem, and I thought I would go through and the thing is there's several things he's got online. This is one of them, and you got to stare at it for a minute, but
What we were working last week was like or Monday was like the centroid with the hole in it, wasn't it?
yeah, this one was this one. So what I was doing, that one, right?
Yeah.
So what I'm doing is I took care of the first and then the second. I didn't take care of the third. And when I started doing it, I started looking at the table and it's like really obtuse looking. So I've got like a situation like this. I thought what I would do first is go in here and pull it off. He says, based on the width of HME, the top vertex of AB with respect to the axis through the centroid. So I was going to start here, and then I was going to double check and make sure that this is correct. That he's basically, oh, he says retrieved. Wonder where that's from. Here, oh, E. Funda. Okay. Oh, that's interesting. So it's better, oh, is this from Wolfram or no? I don't know what, I can't, it's just, maybe I'll work it off of here. That's interesting. Can you do integrals in this thing? Search E find. No, this is just, okay. Huh. So he's got axis of the centroid. He's got on the corner, and for some weird reason on the top. So if I look at isn't that weird? He's got this. Wait a minute. Is this in columns? Wait a minute. CX and CY. Must be the distances to there. That sort of makes sense. The area, BH over 2. There's the X. About the X-axis. Okay, about the Y-axis. Okay, here you go. About the YC. Well, I'm going to try to poking at this thing a little bit and just see, because all I've got left to do is find the IY. So I'm not going to get all stressed out. I'm just going to poke at it. If I can't solve it by the end of the period, I may actually just come in here, because this is all on here. I may come in here on Friday and do it in here. So if I did that, I am not at the centroid. Oops. Not even close. So my thought is the centroid is going to be a third of the way down, so that's going to be a distance of 2. That's going to be a distance of 1. So I've got, if I come down here on the page and just try my best to do something like this and look at this thing, X centroid and Y, well, I'll call it XC and YC because I think that's what he did. Yeah, he called it XC and YC. Oh, that's interesting. Huh. Then he went down, and there's my XC and YC. So let's see. I wonder if I should just, maybe I'll zoom in and then grab it. Just do that. Copy the clipboard and then drop it in there. So that way I don't have to look backwards and forwards. Go. And just, I thought there might have been a, okay. Now, okay, I got to turn around and relate to his A and B. Oh, wait. Okay, so which one am I doing? Okay, I'm having to reorient my brain here. Oh, I'm doing the IY. So I'm doing the, IY. Now I got to zoom in. He's saying he has the B, the H, but he also has the A. But you know what? I'm just annoyed at this. So what I might do is I might just haul off and do an integration instead. And then I might do that and then try to back in this value. So for to do an integration, looking at the I, he wanted to know about this bottom spot, the point down here. Why is it not doing this? Okay, then we can list it like that. So I'm going to try to do it the integration way. If I did the equation of this line, let's see, I'm going to put the X and Y coordinates of these 2 points. And I'm having to refresh my memory. Okay. You know what I'm going to do? I'm going to select everything now. I'm going to select everything. And then I'm going to move it to the right. Just a touch. Uh-oh, I really goofed that up, didn't I? Or did I? No? I'll look at the other screen and write with this screen. So that is location X is equal to 6 and Y is equal to 4. So X equal to 6 and Y is equal to 4. And the upper dot is X is equal to 3, Y is equal to 10. So if I were looking for the equation of this line, Y is equal to AX plus B, and I know this is an oddball way to do it, and So if I stick in the slope A is a minus rise, so it comes up 6 over a run of 3 or a minus 2. So let's see, y is equal to minus 2x plus b. Now I'm going to use these two, each one, to double check my b, find and then double check it. So if I put in 4 minus 2, 6 plus b, then b would be, that'd be 12, move it over, that'd be 16, I think, 12 from that. Now let's double check, make sure I got the slope right. So from here, if I put in 10 is equal to 3 times a minus 2 plus b. Let's see if that becomes the same thing. I think it is, because that'll be a minus 6, move it over, and it becomes a plus 6. So double checking that twice, I am pretty sure that this is the equation of that line. Now if I reformulate the whole question as this, here's my x, here's my y. I have this. I have the equation of this line is y is equal to minus 2x plus 16. Was that right? I forgot already. Yeah. And then this and this and this and this. Okay, let's make sure I got this right. That is 4 to 10. This is 4 to 10. And this is 3 to 6. 3 and 6. So if I'm looking for this, make sure, then I'm going to do it my own way. Is I'm going to slide back and forth. Question is, which way do I do? Do I slide the little d area up and down, or do I slide it the other way? I got an x squared. I can do dx and dy, or I can do dy and dx. You know what I'm going to do? I think, because I have this listed here, I will go, well, I got two choices. Well, I guess I could do this, y minus 16, and then I'll leave that over 2, but then this would be x, or 16 minus y over 2 is equal to x. I got that choice, or I got that choice. But I got x in here. So maybe I want to do the dx first. If I do the dx first, that means I got to go from here, right there, to 6. 16 minus y over 2 to 6, and then I go from 4 to 10. Oops. Now, let's see if I can just use MATLAB, because I'm too lazy to even do that. And it's x squared integrals x a third over 3, and then you substitute. So maybe I should do that. I don't know. Who knows? Anyway, let me shrink it down. That is not shrinking it down. What happened here? Oh. Oh, so if you put your, interesting. Okay, now I gotta figure out where I was. Was I here? Here I am. Okay. So if I integrate this, the integral from 4 to 10 of now x to the third over 3, evaluated from 16 minus y over 2 to 6. And what I'm doing is going from here to there. So this is defined through that equation. And then I go to the top of that, which is 6. Oops, sorry, dy. Or I can just make MATLAB do it. The way I'll do that. SY, MS, XY. So I've changed those as symbolic. Then I'll do integration, of, I think it was x squared, with respect to x from, okay, parentheses, 16 minus y divided by 2 to 6. And then I close the brackets. Okay, that's a pain. But that's okay because the first part, and the second part is, let's see, 6 times 6 times 6, then take a 3. See, from 36 times 2, 72, that's, yeah. So this is y squared over 2 minus 8, is that right? To the third, this is really tricky, because the way you presented that, but that's over 3 plus 72. Now I got to integrate that from 4 to 10. The beauty there is I can go in, call this integral 1. Okay, so integral 1 is symbolic. So now I'll integrate. Oh shoot, did I call it I1 or I1? Was that right? Yeah. Integrate I1 with respect to y from 4 to 10, 459 over 2. Go down. 459 over 2. So I'll go back and check that in a minute. What I'll do, well, first of all, what is 459 over 2? Oh, well, it doesn't help to put it there. Copy, paste. 229 and a half. Oh, shoot. Yeah. 29 and a half. So if I roll back up here, it'll be minus, oh shoot, I already found it. 29 and a half? Was that right? 229 and a half. So now, go to the draw. If I add this, take away that because it has to be taken away. Taking away that, do I end up with the right answer? I have no earthly idea. So I'd have to type all that junk in here. 720 minus 125, 6637 minus 229 and a half. 364.83. So if I add those, oh, that's the wrong pen. 364.83. Okay, I can't read that. So, okay, so that's what I get, 364. And so I think he's just rounding it up. So 365 is about equal to 364.83. So that was a case, for me at least, that instead of trying to decipher all the junk that was on that page, I just as soon do the integration. Because it's a nightmare otherwise. So now, I even hate to actually try to go back and do this, but I might do it, just try to see if I can figure this out. Okay, first of all, it doesn't matter whether it's flipped right side up, upside down, and here's why. Because if you're at the centroid, which is, let's see, the one that's right here, you can flip this thing upside down and right side up, and you'll still get the same value. So the question is, do I get that? I think I copied this over there, but base to the third, height, and in our case, you got an A and an A squared. So if you take, see, there's your interpretation. You've got to, I'm going to take the picture over there too. Let's see. Take the picture with me over there. And this is going to be an attempt, so I already got the right answer. This is going to be a half-hearted attempt to get this a different way, B. Then I'm going to go get the thing on the centroid. Where, right there. Okay, so that's, oh, here it is. Here is the thing about the centroid. Whoa. I'll go ahead and do both, but I don't need the first one. And I'll drop it right there. So I need to zoom in on this thing in order to see it. So if my triangle sits like that, it's 6 high and 3 wide. 6 high and 3 wide. Now, which end, what is the value of A? Is it 0 or is it equal to B? And in this case, that tip, so the distance from there to the tip is actually B, so that tells you that A is equal to 3 as well. Now let's see if we can half-heartedly figure this one out. Okay, B is equal to 3, A, so the triangle itself that I'm looking at is like this. Now, the question you have to ask is, this is the real triangle that we've got. Is the I bar Y equal to the same for here? And if you look at this, I don't know that it necessarily is, but I'm going to go under the assumption right now that it is, and we'll see if out of the result if that's the case. So I've got H is equal to 6, A is equal to 3, and B is equal to 3. Okay, so that means I'm looking for this one. Okay, so give me a second. Let me make sure I put the right numbers in the right places. Okay, so I keep getting this here. A equal to 3, B equal to 3, H equals 6. Now I can do this. So B, 3 to the third, I'm just copying this. 3 to the third, h of 6 minus b squared, 3, that's a minus, h, 6, a, 3, plus b, h, b and h, 3, these are all times, 3 times h, which is 6, times a, which is 3 squared, all over 36. Good grief. Right here, it's just... This is almost like a nightmare. I mean, it technically is a nightmare. 3 to the third, if I copy that down, right, times 6 minus 3 squared times 6 times 3 plus 3 times 6 times 3 squared. God, about 36. Tell you what, before I divide it by 36, I'll just do 162 over 36. Now the next problem is, okay, I've got to go back. Okay, so I have I bar y, but I need I y, so I need the area dx squared that I need to move. So here's my centroid here, here's my centroid here. It would be in the same location, but I need to, in other words, the centroid sits right here. The distance over to here is 3, plus this is a distance of 3, it's not to scale. So this is a distance of 2. So that means that's got to be 5. So this distance is 5 squared. Area, what is this area? It's a good question. What is the area of that thing? It's a 3 by 6. 3 by 6. It is a 3 by 6. And since it's a triangle, half of that. So I got to add this number to that number. This number being that number. Okay. Okay. 5 squared is still 25. Times 3 times 6 divided by 2. I should have done that different. 225. Let's see. 220. Did I do that right? Okay, 225. Let me do that again. Okay. Make sure I type that in right. 25 times 3 times 6 divided by 2. Yeah, I think I'm good. Now, if I add, oh God, what was it? 225? 225 plus 162 over 36. What's that equal to? Okay, still 225 is there, plus 162 divided by 36, 229.5. 200. Okay, let me try that again. 229.5. Is that what I got? I think that might be what I got. Either I got that or something different. Okay, I think I wrote it all the way up. So I got that doing integration and got that out of the tables. And actually, I guess myself, I felt more comfortable doing the integration there. So here is all that nasty integration, which actually Doesn't seem to be too bad to me. Why is it going off the screen? Because, okay. So I take this and shove it off. Okay. And then if I do the table, the silly table, but I feel less comfortable with the table in this case because of the way the table looked. To me, that looks just, I don't know, that's bothersome to me. Let's see what these is. Okay, so perimeter area. Oh, he doesn't tell you. Okay, let's try to see. He doesn't tell you the I. Oh, he does. Okay. Standard beams. I beams. Okay, so then what happens if I click all? Let's just click that one and do. I guess he's supposed to get it. Okay. So he's going through giving you that because there's little arcs here. A lot of these are supposed to have arcs on this part right here too, but here, let's see. Let's just do square I-beams. Square I-beams, all squared. Let's see. Tapered. There's a little bit of taper in that. Uneven. Bigger on top or bottom. Huh? Uh-oh. They want me to pay money? I guess I'm done there. Some of my clients, they have a lot of money. They have a lot of money. They have a lot of money. Where is the people who have no money? Some of our clients, poor professors and poor students, we're not part of this thing. So, oh well, I guess I'm done using that. Okay. Oh, look at that. That's from last time. Okay. So it's the same formula. So I use that. You have to use it at the centroid to move it off somewhere, because if you look at the book, the parallel axis theorem always looks like have a shape, find the centroid, put your coordinates there, x and y. Then you find your I, x, which actually technically should have two x's, but the book, that's basically the I about there and the y about the centroid. And then if you want to put another coordinate system, like what we had to do, this would be the distance in the x, and this would be the distance in the y. And so to find the I, x, well, that place, you gotta do I bar, x bar plus area dy squared. Then you gotta do, this is all in the textbook too. Area times dx squared. So this is the parallel axis theorem. And you have to remember too, it is a little distracting and uncomfortable, but this is the, that was supposed to be area. And this is the equation. So these are straight up. So if you do these, and you do them about a coordinate system, you don't have to use parallel axis theorem, which is what I did. I did it straight up about the coordinate here, because that's what he wanted. I found this was my origin, this is my x, this is my y. So I went in here and found this little triangular part, this part right here. And I have to subtract it off because it's a hole. And I took it and pulled it off, which is why this became a minus right here. I would prefer to do that with integration just because circles and squares are easy to find, those centroids and how you move things around. I just felt uncomfortable about the triangle, so that's why I preferred to do the integration on it. So, I don't know. So, I'm done with that. So, technically, I guess I could do just come in here and work problems. If everybody would send me a suggestion of what to work, I'll just come work them. So I'll send out an email and say, hey, if you want a problem worked, send me an email, I'll work it. It doesn't have to be one of the homeworks, it can be one of the homeworks. If you find something weird in the book and you want me to work it, I'll work it. I'll stumble through it. I mean, I kind of stumbled through this one, and I just really felt uneasy about using this, but it worked out, but I still felt uneasy about it. But feeling uneasy and having that integral, it always works there. So that's pretty much it. So I did not even check. Oh shoot, I should have checked the stream. I usually check the stream when I start. Dang, it's too late now. Come on. Why is it not? Okay, let me see if I can. This is not dynamics. This is statics. No, that's October the 18th. Okay, wait a minute. Oh boy, I hope it worked. Oh, there I am. Am I working? Oh, wait a minute. It says, wait, this is November 10th. Oh, crap. Oh, there I am. Oh, good. Okay, so the stream is working. Okay. All right, so let me stop the stream. It says, wait, this is November